All right, let's look at inverse trig for just a minute. This is what we talked about kind of in class today. Um, when we do unit circle questions, normally you have the unit circle, and I'll ask you a question like, oh, what is the sine of, 2 pi over 3? And so I'm giving you the angle, 2 pi over 3, so you find 2 pi over 3, and sine means the y-coordinate, so you would answer with root 3 over 2. With inverse trig, what we're going to do is actually go backwards. I'm going to give you the coordinates for the sine or cosine value, and you have to tell me the angle where that value is found. So we're going to go in the exact opposite direction, and that's what we're looking at here with cosine of theta equals 1. I'm asking at what angle is cosine equal to 1. Cosine is the x-coordinate, so I see an x-coordinate of 1 right here, and that happens at an angle of, you could either say 0 radians, or 0 degrees. Whether you answer in degrees or radians, it just depends on the directions. Normally I lean towards radians, but for now I may use degrees a little bit more heavily because we're more familiar with degrees. Where's the angle? Theta, where sine, which is your y-coordinate, equals root 3 over 2. I'm looking for a y-coordinate of root 3 over 2. That happens twice. That happens at 60 degrees and again at 120 degrees. So those will be our answers. By the way, degrees is a unit. I don't know how picky I would be, but technically, if all you write is 60 and 120, it wouldn't be right because you left off the units. Your units are degrees. So if you're answering in degrees, remember to put the degree symbol up there. The only time I'm not going to care if you omit it is when we're doing unit circle quizzes. If you leave the degree symbol off on the unit circle quizzes, I'm okay with that. So anyway, so that's kind of the idea behind inverse trig. You're given the value and you work backwards to get the angle. So let's talk a little bit more details about inverse trig. As I said, it's used to find angle measures. And in this example right now, I'm just going to use inverse sine. Some of the notation, and I'm not a huge fan of the notation, especially this one. People read that often the wrong way. I don't like this thing. I don't like that because when people see that, they think it's an exponent, but it is not an exponent. That is not sine to the negative 1 power. That is simply read inverse sine. It is not sine to the negative 1. There is a reason that notation exists, but I'm not a big fan of it because it's very confusing. But this is simply read inverse sine, not sine negative 1. Arc sine is the exact same thing as inverse sine. It's two different ways of writing the same problem. So if you see inverse sine of something or arc sine of something, they're both asking the same question. And the example I want to look at right now is the inverse sine of 1/2. And what that's asking is, it's asking you to find the angle where sine theta equals 1/2. So when I'm working this problem, let me move on. When I'm working this problem, inverse sine of 1/2, this right here is actually more of a thinking land type thing. That's kind of what the problem is asking. It's asking, where is your sine 1/2? Well, sine is 1/2. Well, 1/2 is our y-coordinate, so I see y-coordinates of 1/2 in two different places. I see it at 1/2. I see the 1/2, and that happens at 30 degrees and 150 degrees. So those are the two angles where sine is equal to 1/2. Excuse me for a second. So those are the two angles where sine is equal to 1/2. We're going to come back in just a second and modify our answer a little bit. But that's the idea behind sine. So let's see. Let's try another one. Let's do the arc cosine, which is the same thing as the inverse cosine of negative 1/2. And in my head, when I'm working this problem, it's basically the same thing as saying find the angle where cosine is equal to negative 1/2. That's our thought process for this. I know that cosine is x-coordinate, so I'm looking at my unit circle, and I look for an x-coordinate of negative 1/2. That happens right here, and it happens down here. So the angles where cosine is equal to negative 1/2 are 120 degrees and 240 degrees. And so we have two angles. Now, the two angles are the ones that show up on the unit circle. I could actually, if I really wanted to, I could come up with a whole bunch of other answers where my cosine is negative 1/2, And the way we do that, the way we would do that is I would start at my angle. Like, let's say I'm starting right here at 2 pi over 3 or 120 degrees. If I start at 120 degrees and then I go a little bit crazy here and I move all the way around my circle. So I'm starting at 120 degrees and then I go on a trip. I go all the way around, all the way around, all the way around, all the way around, and I go all the way around another 360 degrees. So if I start at 120 and I go in a whole circle around, well, 120 plus 360 gives you an answer of 480 degrees. And 480 degrees is another angle, even though it's a bizarre angle, it's way beyond our normal unit circle. That is another angle where the cosine of 480 would be negative 1/2. Likewise, I could add, I wonder if this will work. This is going to be crazy. Let's see. I could do the same thing with 240. I could go all the way around my unit circle at 240. I'm just going to get rid of that. Now that's confusing. This is scaring me. Oh my goodness. Okay. So if I start at 240 and I go all the way around my unit circle, 360 degrees, then the next time I get back to that same place, 240 plus 360 is 600 degrees. And then I could keep adding 360, and I could add 360, and I could add 360 a million times and come up with a whole bunch of different answers. So what we have to do is come up with a way and a rule to follow so that everybody always gets the exact same answer when you're answering inverse trig questions. And the rules we have is we have certain restrictions. If you see an inverse cosine question, you always answer between two particular angles. And for inverse cosine, the angles we always look at all angles on the top half of the circle. So for inverse cosine, it's almost like the bottom half of the circle doesn't exist. And the reason we don't need the bottom half of the circle is because I can hit every single x coordinate on the top. My x's on my unit circle go from -1 to +1, and I hit every single one of them on the top. So when I'm answering a cosine question, which refers to x coordinates, I only need to look at the top half of the circle. And if I only give the answer on the top half of the circle, then the angle I'm worried about is 120. So nobody would give any of these answers. So for inverse cosine, we only answer on the top half of the circle. Let's go back and think about inverse sine. That's the problem we're working at right here. Inverse sine, remember sine is your y coordinates. So if I'm answering a question about the y coordinates, then I know my lowest y coordinate is -1. My highest y coordinate is +1. I can hit every single one of those y coordinates on the right half of the circle. So if I only look at the right half of the circle, I can get every single one of my y coordinates, going from -1 all the way up to +1. I don't need to look at the left half because any y coordinate over here can also be found on the right side. So for my inverse sine, if I need sine to be 1/2, well, that happens right here at 60 degrees. Sorry, it happens right here at 30 degrees. And I don't need to give the 150 degree answer. We'll only answer with 30 degrees because that's the angle that's on the right side of the circle. So that's kind of our restrictions. For sine, we only look at the right side. For cosine, we only look at the top half. And the rest of the restrictions, let's go ahead and list them really quick. Inverse sine equals some angle. You always give the answer that's on the right half of the circle. You always give the angle on the right half of the circle for inverse sine. Now the tricky part is, actually I may come back and answer inverse sine in just a second. But I do know that inverse sine is always on the right half of the circle. Inverse cosine, we said you always look on the top half of the circle. So you always start from 0 and you go all the way over to 180 degrees. So that's 0, this is 180 degrees. So your answer to an inverse cosine question, you always give the angle between 0 and 180 degrees. Or if you're in radians, that's between 0 radians and pi radians. So inverse cosine, you always give the answer on the top half. For inverse sine, your angle, you start down here and then you work your way up to the top. The tricky part is, I'm going to start with the easy part. The easy part is you stop at 90 degrees. You stop at the top. That's the high angle. The tricky part is the bottom angle. Rather than calling this 270 degrees, I'm going to call it negative 90 degrees because that's the same thing, but negative 90 degrees simply means you go backwards 90 degrees. So your answer for inverse sine will always be between negative 90 degrees and 90 degrees, or if you wrote that in radians, negative pi over 2 to positive pi over 2. You always give the answer between negative pi over 2 and positive pi over 2. And any angle in the fourth quadrant, you use the negative angle. And we'll talk about that in more detail in just a little bit. But you use the negative angle if you give an angle in the fourth quadrant. Cosine, you go from 0 to 180. You don't have to worry about negative angles. Tangent is the same as sine. So if I'm going to do inverse tangent, the restriction for inverse tangent is actually the exact same as sine. We look at the right half of the circle, and that would be from negative 90 degrees. Your answer will be between negative 90 degrees, positive 90 degrees, or in radians, negative pi over 2, positive pi over 2. So you always give the answer on the right half of the circle, and then remember use negative angles for the fourth quadrant. And then you have cotangent, secant, and cosecant. Cotangent, this is confusing. You would think it'd be the same as tangent, but it's actually the same as cosine. Cotangent is between 0 and 180. Secant is the same as cosine. Secant and cosine are reciprocals. So secant's the same as cosine. That's also between 0 and 180 degrees. And then cosecant is the reciprocal of sine, so we're going to use the right half of the circle for cosecant, which would be between negative pi over 2. You have to use those negative angles. Actually, I'm doing degrees here. Let's do negative 90 degrees. And positive 90 degrees. I'm going to pause it and fill in the radians also. All right, so there are the restrictions for your 6 inverse trig functions, and we're going to use those restrictions to answer the rest of the questions I have here. And they don't really take too long. Like, let's look at these two. We have the inverse sine of root 2 over 2. Now, the second I see inverse sine, I automatically am thinking, okay, inverse sine, you only use the right half of the circle. So I'm only going to look at the right half, and sine is root 2 over 2 up here, for my y-coordinates root 2 over 2, and that happens at an angle of pi over 4. So your answer number 2 here, the inverse sine of root 2 over 2, it's pi over 4, because that's the angle where sine is root 2 over 2. Number 3, the inverse cosine of negative 1. That means I need the angle where cosine is negative 1. Cosine is the x-coordinate, is negative 1 right here, and that's at pi radians. By the way, I have flips to answer in radians. Pi radians, if you wanted to say 180 degrees, that would be correct also. Same thing here, pi over 4, or if you wanted to say 45 degrees, that would be fine. Just make sure you include the little unit symbol, the degree symbol. Let's see. So there's inverse sine and inverse cosine. Inverse tangent. I may come back to that one in just a second, because inverse tangent and cotangent to me are the most difficult ones. So we'll come back to inverse tangent. Let's look at this one, inverse secant. Well, this is the same thing as saying, well, I need secant of some angle to equal 2. That's how we think of this. The problem is secant is not something we think about a whole lot. When I look at unit circle, I think sine and cosine. I don't think secant or tangent or anything like that. So if secant is equal to 2, that means that cosine, since secant and cosine are reciprocals, cosine is 1/2. So the inverse secant of 2 is actually the exact same thing as asking for the inverse cosine of 1/2 because the two are reciprocals. Now I'm thinking inverse cosine, you always answer on the top half of the circle. So for number 5, I'm thinking somewhere up here. And cosine is 1/2. That happens right here at pi over 3. So your angle for this one would be pi over 3. Or if you're answering in degrees, 60 degrees. Let's look at the inverse tangent one right there. Arc tangent of negative 1 over root 3. You need to know your restriction, your arc tangent. Let's go back and see. Inverse sine, inverse cosine. Inverse tangent, you use the right half of the circle. So let me go back to my problem. Inverse tangent. we want to use just the right side. And I need tangent to be -1 over root 3. And this is kind of a crapshoot because you're going to have to do a little bit of guessing until you're really good at this. The one thing I do see is that tangent is negative. Well, if you divide sine and cosine and get a negative answer, then sine and cosine have to have different SIGNs, signs. One has to be positive, one has to be negative. So I'm limiting my direction or my attention to the fourth quadrant. And it's one of these three. I'm ruling out 7 pi over 4 because these two coordinates are the same, and if you divide them, you'll get -1. You're not going to get something funky like this. So I'll throw out the 7 pi over 4. And then as far as the other two, you really just guess. You pick either 11 pi over 6 or 5 pi over 3. Let's start with, let's try the 5 pi over 3 one. If I did sine over cosine, I'm just going to test it. If I did my sine, which is -√3 over 2, and divided it by the cosine, which is 1/2, well, let's see. If I did sine over cosine, I'll flip and multiply. So -√3 over 2 times 2 over 1. My 2's cancel, and we're left with just -√3. That didn't work. I needed -1 over root 3. So that fails, which means the answer is probably going to be 11 pi over 6. We'll test it really quick. If I did -1/2 divided by root 3 over 2, that's times 2 over root 3. 2's cancel, and you've got -1 over root 3. That's what I want. So the angle is 11 pi over 6. But if you remember, I told you anytime you answer in the fourth quadrant, you have to answer with a negative angle. You don't answer with 11 pi over 6. So instead of 11 pi over 6, we use, that's the same as negative pi over 6. So our answer number 4 is negative pi over 6. And there's how we answer that one. How much time have I spent? 16 minutes. I think that's probably good. There was some other stuff I wanted to look at, but I think this will be good. So there's your tricks to the unit circle, to inverse trig. The main thing you have to remember is the restrictions. You have to know that sine is the right side, cosine is the top half, and their reciprocals are the same. So if sine is the right side, then its reciprocal, cosecant, is also the right side. If tangent is the top, then its reciprocal, secant, is also the top. The lone exception, and this is confusing, is the tangent and cotangent, because cotangent we look at the top, but tangent we look at the right side. You need to know those restrictions, or else you're going to end up getting some crazy, not crazy, but you're going to end up giving me the wrong answers to these. So there we go. And yeah.